Have you ever wondered how YouTube starts playing a 2 hour or even a 4 hour video almost instantly? Some YouTube videos are over 10 GB, 20 GB, or even 100 GB in size when stored on Google servers. But somehow, after pressing the play button, the video starts within just a few seconds. How is that even possible? Is YouTube downloading the entire video before playing it? The answer is no. In today's video, we'll uncover the complete engineering behind YouTube instant video streaming. We'll explore everything from DNS, CDN, chunking, buffering, adapting streaming, and even why the video quality changes automatically. Let's begin. So first one, where we have got the first step, users open the YouTube. So whenever you are opening or you are trying to see video, obviously you will need an app or a website of YouTube to open it. So everything starts when you open the YouTube website or app. At this point, nothing has been downloaded yet. Your browser is only displaying YouTube interface. You are just seeing the recommendations of YouTube which is given to you. Now suppose you click a video. The moment you press the play button, your browser immediately sends a secure HTTPS request to Google server. This basically says, I want to watch this particular video. And then there comes the next step called as DNS Resolution. But wait, how does it come to know what YouTube servers are? Where YouTube servers are? That's where DNS comes in. DNS stands for Domain Name System. Think of DNS like the contact list inside your phone. Remember people's name, your phone remember their phone number. Similarly, we remember youtube.com. Computer remembers the IP address, which you can see over here. We have got example.com, that is your domain name, and here the one which you see, this is called the IP address. So before contacting YouTube, your computer asks the DNS server and tells, can you tell me the IP address of youtube.com? The DNS server replies with the appropriate IP address. Now your browser finally knows where to send that request. Now, after that, here's something interesting. Google does not have only one server. It has millions of servers spread across the world. Like we are showing here, 3 servers in this picture. This system is called as Google Global Load Balancer, where once your request reaches Google's, another intelligent system takes over. Its job is simple. It decides which server should handle your request. Instead of sending everyone to one computer, this load balancer distributes the traffic across thousands of servers as shown in the picture. This prevents overload and makes YouTube much faster. That is, if one server is busy, the request sent to the clients will go to another server, and similarly like that. Then after that, the request will go towards another technology called as CDN. CDN stands for Content Delivery Network. Instead of storing every video in only one country, Google stores copies of videos in data center around the world. Imagine someone in Nepal wants to watch a video. Would Google send the video all the way from America every single time? Of course not. Then how it works then? We can see in this part over here. So then here we'll cover what is CDN. So actually in CDN we have got different servers across the world. Like for America, we have got US CDN. For people in Europe, we have got Europe CDN. And say if you are in Nepal, then maybe the video comes from Asia CDN, which are also called as data center. And you have to think one thing is that the shorter is the distance between you and the CDN server, the faster the video arrives. That's one major reason YouTube feels incredibly fast. Then after that, once the correct server has been selected, YouTube still doesn't send the video immediately. Instead, it first sends something called metadata. Metadata is simply information about the video. For example, how long is the video? Which qualities are available like 240, 480, 720, 1080 or 4K. Which codec was used? Is audio stored separately? All this information is tiny compared to the actual video. It arrived almost instantly. Now, you two want to know one more thing. How fast is the internet then? It performs a quick bandwidth estimation. This helps you to decide what quality it should begin with. Imagine your internet speed is only 3 Mbps. Starting directly with a 4K would cause buffering. Instead, YouTube may begin with 480p or 720p. On the other hand, if you have got a very fast connection, YouTube can immediately start with 108p or even 4K. This entire process happens automatically. And after this step, the next one will come called as the chunking step. Now comes one of the biggest secret behind the YouTube, that is called chunking. Many people believe YouTube download the entire movie before playing it. That is completely false. You have to understand that. Suppose a video is 2 hours long, instead of one gigantic file, YouTube cut that 2 hour long file into tiny pieces. Each piece may contain only 2 to 4 seconds of video. So rather than downloading a 6 GB of file, YouTube download only first few tiny chunks, for example, the first, second and third chunk. That's enough to start a playback. While you're watching the chunks, the next chunks are already being downloaded in the background. This process continues until and unless the video will end. Before playback start means before the download happens from the server, YouTube creates a small safety area called as buffer. Usually, this buffer stores around 3 to 10 seconds of future video. So that's why whenever you are playing YouTube, you see that there is a red highlighted part, and just in front of red highlighted part, there is a small white highlighted part. That white one is your buffer. You will notice that next time whenever you are opening the YouTube. Think of it like filling a small water tank. As long as the tank contains water, you can keep using it. Similarly, as long as the buffer has upcoming video chunks, playback remains smooth. Now, the player finally starts. But something interesting is still happening behind the scene. The browser never stops downloading. While you are watching chunk 3, it is already downloading chunk 4, chunk 5 and chunk 6. This is why playback appears continuous. And here's something that surprises many people. The video and audio usually arrive separately in YouTube. One stream contains only the video, another stream contains only the audio. Your browser receives both streams independently and then your computer synchronizes them perfectly. Only after combining them does the final image appear on the screen. This separation allows YouTube to switch video quality without interrupting the audio. Once the chunk arrives, then your computer decodes the compressed video. The CPU and GPU work together to convert the encoded data into actual images, as you can see in the picture. These images are displayed one after another, usually 30, 60 or even 120 frames every second, and it depends totally upon your hardware, upon your device. To your eyes, they appear as a smooth motion. But is that all? Not quite. YouTube keeps monitoring your internet every few seconds. If your connection suddenly becomes faster, YouTube upgrades the quality automatically. For example, 720p becomes 1080p. Later, 1080p becomes 4K. Most users don't even notice the switch. While now imagine your Wi-Fi becomes weak. If your YouTube continues downloading 4K chunks, the buffer will eventually become empty and the video will stop. To avoid this, YouTube immediately switches to a lower quality. For example, 1080p becomes 720p, and if necessary, if your internet is very slow, 720p becomes 480p. Lower quality chunks are much smaller, so they download much faster. This keeps the video playing without interruption. This entire process repeats every few seconds. Download new songs, maintain the buffer, check internet speed, adjust the quality, display the frames, and just repeat and repeat the same step. All this happen continuously until the video ends. Now, now you know the real reason YouTube feels almost magical. It does not download the whole video. Instead, it finds a nearest server, uses a CDN, download only small songs, maintain a smart buffer, stream audio and video separately, continuously check your internet speed, and automatically adjust the quality in real time. That combination of technologies is what allows you to watch even massive videos almost instantly. The next time you click on a YouTube video, remember that thousands of engineering decisions are happening behind the scene in just a few milliseconds. If you enjoyed learning how YouTube really works, don't forget to like the video, subscribe to the channel, and let me know in the comments which technology you would like me to explain next. Thanks for watching, and I'll see you in the next video.